Hi everyone, this is Professor Oaks, and in this video we are going to talk about adding and subtracting rational expressions. So, in general, what we will do is if the rational expressions have the same denominator, we will have a over b plus c over b. This is a plus c over b. All right, both denominators the same. But if the denominators are different, a over b plus c over d, then it's just like adding fractions, right? So a times d plus b times c over b times d, and then we would simplify at the end. All right, so if you look at the first example here, 9 over 7t minus 2 over 7t, these have the same denominator, so we just subtract the numerators. So 9 minus 2 over 7t, and then 9 minus 2 is 7, so we have 7 over 7t, and then the 7s can divide out. So 7 divided by 7 is 1, so we have 1 over t. There you go. Now, let's say, for example, we did not recognize that these already had a common denominator, and you had 9 over 7t minus 2 over 7t, and you went ahead and you multiplied the 9 times 7t minus the 2 times 7t all over 7t times 7t. Well, that wouldn't be wrong. It's just it would be a little bit more work for you, right? Because now what you have to do is 9 times 7t, that's 63t, and 2 times 17, that's 14t, and 7t times 7t is 49t to the second power. And then you have to go ahead and subtract the 14t from the 63t, right? And so that would be, what would that be? That would be 49t over 49t squared, and then the 49s divide out, so you have t over t squared, but then one of the t's divide out, so it's 1 over t, and you still get the same result. So if the denominators are the same, it makes the procedure of adding and subtracting the rational expressions a little bit easier. So that's our goal, is to try to make things as easy for us as possible. So if I have 5 over AB minus 3 over A, I see that both of the denominators have an A, but now I want them both to have a B also. So I can multiply the 3 over A by B over B. So now they both have AB as their denominator. All right, so of course, if I divide out the b's, then I get back to my original problem. So I really haven't changed the overall expression at all. In fact, I haven't. So then, now that these are both the same denominator, AB, I just subtract the numerators, so we have 5 minus 3b over AB. So where is that result here? That is, let me find it for us. That is right here, 5 minus 3b over AB. So let's try another one. So we have 1 over 5x plus 2 minus 1 over 4x. All right, so we have 1 over 5x plus 2 minus 1 over 4x. So I see here that this denominator has a 5x plus 2, but this denominator does not have that. So what I will do here is multiply by 5x plus 2 over 5x plus 2. So now they both have 5x plus 2, but now I see that both need a 4x. So 4x times 5x plus 2, 4x times 5x plus 2. So now they both have 4x in them as well. So as long as I make sure that both of the denominators are the same, then I can go ahead and just subtract the numerator. So 4x times 1 is 4x, then minus, don't forget to think of this as minus 1 times 5x plus 2, right? And then it's all over 4x times 5x plus 2. Why is that minus 1 important? Well, I need to distribute the minus 1 or the negative 1. So I have 4x minus 5x minus 2 all over 4x times 5x plus 2. Then combine the like terms. 4x minus 5x is actually negative 1x or negative x minus 2 all over 5x times 5x plus 2. And there you go. That is my answer right here. So I hope that you enjoyed this. So let's try another one here. So we have z minus 2 over 8z minus z plus 2 over 4z. And then I see that they both have a z. And then if I want the lowest common denominator, then hopefully you can see if I multiply 2 over 2 here, then 2 times 4 would be 8, and then both of the denominators are now 8z. All right, so now just make sure that you see how I wrote these constants here, because I'm ready to subtract. So I have z minus 2 minus 2, and then remember I put the parentheses here just like I did with the minus 1 in the last example, so that I don't forget to distribute that negative 2. So then if I distribute, I have z minus 2 minus 2z minus 4 all over 8z. And then I combine the like terms. So I have here z minus 2z is negative z. And then I have, okay, I'll pull up the paper for you in a second. Don't worry. So then we have minus 2 minus 4, that's minus 6 all over 8z. So there is my solution, negative z minus 6 over 8z. So let me show you that that matches what is one of the answers right here. All right, so hopefully you enjoyed that one. So now it's time for another one. So we have 8x minus y over 2xyz plus y minus 8x over 2x, or is it? Yeah, 2xyz. So these both have the same denominator already. So it's just 8x minus y plus y minus 8x over 2xyz. And then we combine the like terms. So 8x minus 8x zeroes out, and negative y plus y zeroes out. So we're left with 0 in the numerator. So we have 0 over 2xyz, which is 0. What a time to be alive. All right, let's try another one right here. So here is an example where the denominators are actually all both the same already. So y squared z squared minus 3y plus 2 over 5yz plus 3y minus 2 over 5yz. So we have y squared z squared minus 3y plus 2 plus 3y minus 2 all over 5yz. So then I look to see what can be combined or zeroed out. So we have 3y and negative 3y zeros out, and we have 2 minus 2 zeros out. So then I'm left with a, well, let's write this here. So we're left with y squared z squared over 5yz. So if I divide out one of the y's, so that's y, z, z, 5yz. So one of the y's can divide out and one of the z's can divide out. So I'm left with yz, all right, yz over 5. And that is the answer I have right here, yz over 5. I hope that you enjoyed that example. So let's move on to another one here. So now This one is going to be a little bit more complicated than the last one here, but all we have to do though is just try to make sure that we get the common denominator. So let's go ahead and start by factoring this denominator right here. All right, so 2 over x plus 3 minus x squared over, and then if I factor x squared minus 4x minus 21, I have x plus 3, x minus 7, and then plus x plus 4 over x minus 7. Now I see this is fairly convenient because I see that two of the terms have an x plus 3 in the denominator. So I need this one over here to have an x plus 3 in the denominator. And then I see now that two of them have an x minus 7 in the denominator. So I want all three of them to have an x minus 7 in the denominator. So I'll multiply the first term by x minus 7 over x minus 7. So now all three of these have a denominator of x plus 3, x minus 7. All right, what a time to be alive. Now, I just go ahead and I do the simplification in the numerator. So I have 2 times x minus 7 minus x squared plus x plus 4 times x plus 3. Be careful again of how I write these. So I'm writing all of the binomials or all of the factors with two terms in parentheses so that I don't forget to distribute. And even the constant over here, see I wrote the x minus 7 in parentheses so I don't forget to distribute the 2. So I have 2x minus 14 minus x squared and then plus. And then remember, if I multiply x plus 4 times x plus 3, I have to multiply x times x to get x squared, then x times 3 to get 3x, then 4 times x to get 4x, and then 4 times 3 to get 12. All right, and then that's all over x plus 3, x minus 7. And then because this is just adding here, I don't actually need to distribute any number across the parentheses, so I just combine the like terms. So x squared plus x squared zeroes that out. Then I look for the next set of terms to combine. So 2x plus 3x plus 4x. 2 plus 3 is 5 plus 4 is 9. So I have 9x. And then I have a, what do I have here? I have a minus 14 and a plus 12. So that's minus 2. And that will be over the x plus 3, x minus 7. So all over x plus 3, x minus 7. And you can see that is the answer right there. What a time to be alive. All right, so let's try another example here. So here we have 6m over 3m minus 12m over 6m plus the 21m to the second over 7m. So this one actually is even easier than you might think, because what I am actually going to do is say, well, 6m over 3m, well that is just 3. And then 12m over 6m, well, that is just going to be 2. All right. And then what do we have? Actually, yes. So that is going to be. Oh, actually, I wrote it down wrong. That's 3m. So that should be 2. There we go. I wrote it down wrong. So 6m over 3m is 2, and 12m over 6m is 2. Then we have 21m squared over 7m. So 21 over 7 is 3. And then we have m squared over m. That will be m. And then I simplify. So 2 minus 2 is 0. So that zeroes out. So I'm left with 3m. So the answer is 3m. What a time to be alive. All right. So you can see there is the answer of 3m. Let's try another one here. So we have y minus 3 over 3y minus y over 3y minus 9. So we have y minus 3 over 3y minus y. And then I'll factor out the greatest common factor of 3 here. So over 3 times y minus 3. Then I see that both denominators now have a 3, and so now the second term needs a y so that they both have a y, and the first term needs a y minus 3 so that these both have a y minus 3 in the denominator. Now the denominators both have a 3 and a y minus 3. Now I go ahead and I simplify the numerators. So remember, it's y minus 3 times y minus 3 minus y times y, which is y squared. Then y times y is y squared. Y times 3 is 3y, so minus 3y minus 3y. And then minus 3 times minus 3 plus 9 minus y squared all over 3y times y minus 3. Then I combine the like terms, so y squared minus y squared zeroes out. So then I am left with a negative 3y minus 3y, that's negative 6y plus 9 over 3y times y minus 3. Then I will go ahead and factor out well, here's the one thing that I might actually write this instead of negative 6 plus 9, negative 6y plus 9 is 9 minus 6y over 3y times y minus 3. And then I might go ahead and factor a 3 out of the numerator to get 3 times 3 minus 2y over 3y times y minus 3. And then I see I can divide out a factor of 3. So I'm left with 3 minus 2y over 3 times y minus 3. What a time to be alive. All right, let's try another problem right here. So, you know what? I will write that at the top of the next page just to make it easier for us so that the paper doesn't keep on sliding down. So it was 2p over qr minus q over pr minus 2r over pq. So this is similar to some problems that we've had before. So you see that the first and the last term both have a q. So we need a factor of q in the denominator of this middle term here. And then we see that the second and the third term both have a factor of p. So we need a p in the denominator of the first term, and now we need an r in the denominator of the last term. So now all of these have the denominator of PQR. And again, it doesn't matter what order you write these in. It can be RPQ, QPR, QRP, as long as P, Q, and R are all in the denominator. So now we'll multiply 2P times P is 2P to the second. Then we have q times q is q squared, so minus q squared. And then 2 times r is r to the second, so 2r to the second. So we have 2p squared minus q squared minus 2r squared all over pqr. And there is our answer right there. All right, let's look at the next one here. So we have 5d over 5c plus 2d, then minus 2c over 5c minus 2d. And we see that the first term has 5 plus 2c in the denominator, but the second term does not. So I'll multiply by 5c plus 2d over 5c plus 2d. And then we see that the first term needs to have 5c minus 2d in the numerator and denominator here, so that both of the denominators now will be 5c minus 2d times 5c plus 2d. So here we go. We have 5c plus 2d, 5c minus 2d in the denominator. And then let's distribute in the numerator. So 5d times 5c is 25cd or dc. And then 5d times 2d will be 10d squared, so minus 10d squared. Then remember we have minus 2c times 5c and minus 2c times 2d. So minus 2c times 5c is going to be negative 10c squared. And then we have negative 2c times 2d is going to be minus 4cd. And so then I combine the like terms. So we have 25cd minus 4cd. That will give us, what will that give us? That will be 21cd, then minus 10d squared minus 10c squared. And then you can't really see that very well. I apologize for that, but let's use a different color here just to make sure that you can see it here. So the denominator is a difference of two perfect squares, so a plus b, a minus b, or you could just multiply it out the long way, but it's really just a squared minus b squared, all right? So if I multiply it out the long way, 5c times 5c, 25c squared, then minus 10cd, then plus 10cd, and then minus 4d squared, I notice that the 10 CDs actually zero out. So I'm left with 25c squared minus 4d squared in the denominator. And then if I do some rearrangement of the terms, I can make sure that I get this to be 21cd minus 10c squared minus 10d squared instead of 21cd minus 10d squared minus 10c squared. See, the answer, it's minus 10c squared minus 10d squared, but it doesn't matter if it's that or minus 10d squared minus 10c squared. So just make sure that you notice that these are the same thing. So 21cd minus 10c squared minus 10d squared. There you go. What a time to be alive. All right, so let's do just a few more here just to wrap it up, because I know that you're truly enjoying this. At least I hope that you are. So here we go. All right, so let's try to keep it together here, everyone. So we have x plus 8 over x squared minus 64 minus 2 over x minus 8. So I need to make sure that I start by factoring the numerators and denominators. So I have x plus 8 over, that's a difference of two perfect squares. So x plus 8, x minus 8, and then minus 2 over x minus 8. Now, if you look easily and carefully here, look, these are both x plus 8, so x plus 8's divide out, and then you have, well, 1 over x minus 8 minus 2 over x minus 8, and these already have a common denominator. So it's 1 minus 2 over x minus 8, and then 1 minus 2 is negative 1. So negative 1 over x minus 8. What a time to be alive. All right. So now here's another one. 1 over CD minus 2 over C. And then I'll write the 3 as just being 3 over 1. And then I notice that the first and the second term have a C in the denominator. So I'm going to multiply the third term by C over C. And then the first term has a d, but the other ones do not. So I'm going to multiply by d over d and d over d. So now all three denominators are cd. Or if you're wondering about that one cd. All right. So then I just subtract and add in the numerator. So 1 minus 2d plus 3cd. And there you go. That is the answer for that one. What a time to be alive. All right, so just a few more short examples here, just so that you make sure that you know exactly what's going on. All right, so hopefully you're still watching. If you're hearing this, of course you are, right? So now we have, and remember that marker was not the good one, so I won't use that one again. Let's just pick this one here. So I have 3 over 4a squared b minus 9 over 4ab. So I see that both denominators have a 4, and both denominators have a b, and then one of the denominators has 1a, and the other denominator has 2a's. So I will multiply the second term by a over a so that they both have an a squared in the denominator. All right, so if I do that, the common denominator is 4a squared b, and in the numerators I have 3 minus 9a. So there we go. That is the answer for that one. 3 minus 9a all over 4a squared b. What a time to be alive. Let's try another one here. So we have n to the third minus 2 over n to the fourth minus n squared plus 1 over n to the third plus 3 minus n over n squared. So I notice that here in the first denominator I have 4 n's, here in the second one 3 n's, and here in the third one 2 n's. So I want them all to have the same number of n's, so I can multiply this one by, well, let's go n over n. So now that there's n times n to the third here in the denominator, it's n to the fourth. And here I have, well, I'll need 2n, so n squared, n squared. So n squared times n squared is n to the fourth. Now they all have the same denominator of n to the fourth. So it's all over n to the fourth. So what do I have? I have n cubed minus 2. I'll distribute a negative n, so negative n to the third minus n, and then distribute n to the second, so plus 3n squared minus n to the third. So then if I look at what's going on here, I see that if I combine the like terms, n to the third minus n to the third zeroes out, but I still have a negative n to the third here. And then I'm left with, if I write this in descending order, a 3n squared, and then a negative n, and then a negative 2, and then all over n to the fourth, and there is my answer. What a time to be alive. I really hope that you enjoyed this video on adding and subtracting rational expressions, and I hope that you're already looking forward to the next one. Thank you and have a great day.